Hi there. In this project, I built a machine learning model to predict the net hourly electrical energy output of a power plant using environmental data. This is the final project of my Machine Learning Foundations for PMs course with Duke University. I'll take you through my approach and findings now. During the course, we learned about the CRISP-DM process for model creation, and this project really focuses on a simplified version of step 4, which is model creation. I chose to evaluate two different model types to see which would better represent the relationship between our features and our target. The first model would be a multiple linear regression model, acting as our baseline, and the second, a random forest regression model to better model nonlinear relationships. The data used for training and evaluating models came in the form of 9,658 rows of environmental data. You can see the features available here. And our target was the net electrical output of the power station in megawatts. Given we were trying to predict a continuous numerical output, this was a regression problem, not a classification problem. And to evaluate models, I chose root mean squared error, or RMSE. This would tell us on average how far off model predictions were in the same units as PE, megawatts, so it was easily interpretable. The first step was organising data. I'd then create and evaluate the models, run the chosen final model on the test data set, and then share a wrap-up of the project at the end. So we split our data into three sets: a training set, which was 70% of the rows, a validation set, which was 10% of the rows, and a test set, which was 20% of the rows. The first model I created then was a multiple linear regression model using the training data. You can see the output here from Excel. Excel estimates one intercept and one coefficient for each feature, which represents how strongly each environmental variable impacts power output, assuming a linear relationship. Once the model was trained, I applied this fixed regression equation only to the validation set to generate predictions for model comparison. Averaging the squared error gives us the root mean squared error of the regressional model, which came out at 4.42 megawatts. I then trained a random forest model using the exact same training data. Excel can't run or train random forest models directly, so I used an external tool or Google Colab to train the model and generate predictions for the validation set, and then I brought those predictions back into Excel. After computing the random forest validation RMSE, the result was 3.33 megawatts. Since this error is noticeably lower than the regression model's validation error, the random forest was selected as the final model. I didn't use the regression model for any analysis after this point. After selecting the random forest, I evaluated it one time on the holdout test set of data, which the model had never seen before during training or validation. The final test RMSE for the random forest was 3.28 megawatts. This means on completely unseen data, the model's predictions are typically within 3.28 megawatts of the actual power output, and this number represents the model's real-world performance. Just to wrap things up, in terms of model interpretation, the random forest model was better able to capture the more nuanced and non-linear relationship between the features and the target. In terms of real-world value, this model could be used to target near-term power output, but I think it would be more valuable if it was combined with a demand forecast to help better match supply and demand expectations to avoid overproducing power or reduce the risk of shortages. And that could also be used to create a model outcome, say the value of the energy saved by avoiding overproduction. And in terms of additional improvements or refinements, I could have looked at tuning or tweaking the hyperparameters, say adjusting the number of trees in my random forest model or the tree depth, or looked at a different validation process than the one I used. To wrap things up, I framed this as a regression problem, and I built and compared a linear regression model and a random forest model. The random forest, based on the validation performance, was selected and I then evaluated it on the holdout test set, which gave us an RMSE of 3.28 megawatts. Thank you.